Welcome back to our channel. Today we will solve question number 7 of exercise 2.2. The question given is dy divided by dx is equal to e to the power 3x plus 2y. What is the differential equation? Now, if anyone who don't know about differential equation in past order differential equations, they have to what our previous values. And this is a differential equation. We will solve this by separable variable method. We will find out the general solution of this given differential equation, what is required in this equation. Now, if anyone who have any sort of question related to separable variable method, so they also have to what our previous value. There we have explained separable variable method in detail. Now let's come to the solution. The question is dy divided by dx is equal to e to the power 3x plus 2y. Now as we are solving this equation by separable variable method, so first we will separate the power of e. In the power of e, there is two types of variable, one is x and one is y. So we have to separate these both types of variable. This is the first step which is we commonly use in separable variable method. E to the power 2y. Now let's shift the e to the power 2y to the left side of the equality and dx to the right side of the equality. And here we will get 1 more e to the power 2y dy is equal to e to the power 3x dot dx. Now let's shift the e to the power 2y to the denominator. Now let's apply integration to both sides of the equality, and we will get integration to the minus 2y e to the power minus 2y dy is equal to integration to e to the power 3x dx. Now further we will solve this equation by supposition variable method. Let's suppose the power of e, let t is a variable which is equal to the power of e, that is minus 2y, and let's call it equation 1. Let's call this term is a and this term is b. These are both terms in which we will use supposition. Now let's apply derivative to this t with respect to y variable. We will get, if you apply derivative to the right side, we will get here just minus 2. So shift dy to the right side of the equality, we will get this. Let's call this equation 2. Now on the right side, let w is another variable that is equal to 3x. Let's apply derivative to w with respect to x variable to both sides, and we will get on the right side only 3. Here also is the same, shift the dx to the right side and we will get 3 dx, and let's call it equation number 4 and let's call it equation number 3. Now we have to replace the power of e here, the power of e by t. We have to replace here the power of e by w. So let's make supposition in equation in the term a minus 2y we replace by t dy. On the right side also replace the power of e 3x by w. Now we have to multiply and divide this term by 3, and we have to multiply and divide this term by minus 2. Why? Because we will get here minus 2 dy, and then we will replace minus 2 dy by dt, and here we will replace 3 dx by dw, and then we will apply integration. Now we cannot apply integration because the power of e is t and the integration is with respect to y variable. So in different variable, this term will consider as constant. So then we will get e to the power ty, which is not required general solution. So you will multiply and divide the left side by minus 2, and we will get minus 2 dy. It's like minus 2 integration e to the power 2 t, sorry, minus 2 dy, and let's divide and multiply the right side by 3, and we will get 1 over 3 integration e to the power w dot 3 dx. Now we will replace 3 dx by dw and minus 2 dy by equation 2. So we will get here minus 2 e to the power t dot minus 2 dy by equation 2, which is dt. We will replace minus 2 dy by dt according to the equation 2nd. The right side e to the power w, we will replace 3 dx by equation 4, which is dw. Now the variable in integration is the same. We'll apply integration with respect to t variable to e to the power t, and you will get here just t e to the power t, because as the derivative of e to the power t is e to the power t, so as the same as the integration of e to the power t will also be e to the power t. On the right side, we'll also get here e to the power w, same case, and plus c. Now we have to replace the t in w in the power of e's. As we have supposed t is equal to minus 2y in equation 1, so we'll replace e to the power, replace the power of t by equation 1, and you will get here minus e to the power minus 2y divided by 2. On the right side, we will get e to the power w. We will replace w by equation 3, where it is 3x divided by 3 and plus c. Now we have to shift 2 to the right side and 3 to the left side for rearranging this equation. Now this is not required. This is also a general solution, but we will just rearrange this equation. We will get here minus 3 e to the power minus 2y, and here we will get 2 e to the power 3x plus 3c. Now the 3c will give us again any other constant, so you write it is, let's call it c1, and this is now the required general solution in arranged form. Thank you.